by, and we're ready to start. Okay, thanks.
Hi, good morning. I'm Jonathan. I'm very honored and excited to represent our team, USTC-Software, to introduce our work, BioPanel. Professor Herman from University of Maryland once published a paper with his co-worker on future science. He suggested that CDI-GEM signaling and chromosomes might well be linked together, but didn't point out that explicitly. So there is how BioPanel came to our mind. Following his idea, we set the main mission for our BioPanel. The mission is let people be able to easily find out connection among various substances inside the organism. And I'm proud to say we finally successfully accomplished this mission. This is the pathway between signal, CDI-GMP signaling and quantum sensing we found by BioPanel, and we also found two papers which can demonstrate this pathway indirectly. My teammate Longzhi will explain it later. So now let's take a quick look at our worries of this mission. To start, we will research something familiar to us. Here is an offering called DOSCP. If you want to know other substances that related to one node, just double-click on this node and what you want will pop out. After expanding several times, the graph might look messy. You can use the smart layout function to rearrange this graph for making it clear and to easier understand. The nodes in graph are various substances inside organisms such as operin, gene, enzymes, and other something else. And we also use the color of edge to represent different effects between substances. For example, in default setting, blue line means catalyzed and red line means repressed. We can repeatedly search and expand to get a graph which probably means a real functional network in biology. So next, the most fantastic part comes, the pathway finder function. If you want to search, find out connection between two nodes, the pathway finder function will search that for you in our database quickly and easily. When the result shows, you can select the appropriate one and input that into our canvas. Yes, this is the pathway. The node was shown with the light highlighted is pathway we found by this in this demo. Okay, there is the end of our basic function introduction of BioPanel. So next, let my teammate Longzhi to show you how BioPanel solve a real biological problem as we said before, how to find the connection between CDI-GMP signaling and quantum sensing. Let's welcome.
So just as Johnson mentioned earlier, we managed to find the actual relation between CDI-GMP signaling and quantum sensing. And right now, I'm going to show you the exact process of how we find them with BioPanel. And by doing so, I would like to show everyone here what amazing things you can achieve with BioPanel. And let's take a look at the video. So first, we search the CDI GMP out and add it into the canvas. And to get more nodes, expand CDI GMP, and then expand the 2 nodes of reactions to see the details. Of course, if you wish to be a little more careful for CSGD, you can choose CSGBAC from the expansion list and add it to the network. And then use smart layout to organize the network and make it better to look at. So now we have our first network of CDI GMP signaling. And next, we are going to try to get quorum sensing pattern into this network. And so we are going to do as is shown in the previous video. We can search LSRK protein out and add it to the network. And then we can expand the nodes, and then expand the nodes which follows it. And after searching and expanding for several times, we'll be having the 2 separate networks of CDI GMP signaling and quorum sensing. And right now, we are going to try to find the relation between CDI GMP and quorum sensing, and that comes to our function of pathway finder. So we first select CDI GMP and CMP CRP, and then use pathway finder to look for possible routes between them. And we limit the number of results which is going to be given. So you are seeing only 5 shortest routes here. And then import it into the network. And finally, use smart layout to organize the entire network again. So right now, we have our final network we want. And now let's take a closer look at the network to see what we can find. So as you can see on the left side, the CDI GMP is antagonistically controlled by the sigma S activated GGDF protein and the EAL type phosphodiesterase. Meanwhile, CDI GMP promotes the expression of CSGD, which encodes an activator of the Curtis structural transcription unit, CSGBAC. And on the right side of this graph, LUX catalyzes the synthesis of a signaling molecular AI2, which after phosphorylation by the LSRK kinase, combines with the LSRR protein to become a complexes and end the suppression of LSRR towards the expression of LSR transcription unit. And these are what we can get for from the graph we built. And I'm very glad to say that our results is supported by 2 published papers. The first one is written by Zhou Xianxuan, and the second one is written by Christina Jonas. So that's what BioPanel has accomplished to show us the connection between CDI GMP signaling and the quorum sensing, and lead us to a better understanding in the series of biofilm formation and the virulence factor production. And with all these factors, we believe that BioPanel will aid you to accomplish more and more in synthetic biology in the future. So that's it for the example, and now let's focus on the technical details. As you can see here, BioPanel consists mainly of 2 parts, the back end and the front end. And the front end is mainly, the main task of front end is to show a pretty and friendly interface to the users and accept the request from users and pass it to the back end. While the back end is mainly invisible, but it actually does a lot of work. It is used for managing the database and solving the request which comes from the front end. Our back end runs on the remote server, so it is linked with the front end with special APIs to ensure that the data transmit efficiently. And now let's look at the backend. So our backend is mainly a database, and during our research, we built our database which can extract data from 3 major biological databases, the regular DB, KGG, and UniProt. And we recognize their data and merge them into a new one to form ours. Additionally, modification from users will be synchronized to our database And all these measures will make sure that our database will always meet your needs. And of course, by using our user-friendly and functional front end, you'll be able to create a biological network easily and quickly. And here are the 3 features which makes that happen. So first, we use the Adobe Air platform and the ActionScript programming language to ensure that BioPanel would be able to run on any platform which supports Air. And second, we use the technology of multi-threading and GPU accelerating to make sure that our layout function is 1,000 times faster. And third, not only can the front end communicate with our backend, it is also capable of connecting to the internet. And so you can search for more information on the internet. For example, you can use BioPanel to search for references online easily. And that's it for the technical details. Next, I'm going to leave it to my teammate Zhang Zhiyuan and let her tell you about our future work and the PMP. Thank you.
Okay, now I would like to tell you about our future work of our team. Currently, our team is working on three goals to improve our software. The first one is that we are trying to make our software able to update on time so that we can keep in pace with the newest database that is actually working in biological science. And the second one is that we are trying to build up a criteria to evaluate the reliability of all the data. And the third one is that we are trying to build up the links of equivalence for all the synonyms in our network. Okay, now I would like to tell you about the policy and human practice part. Firstly, I would like to introduce about our teamwork management. We have, in order to make our teamwork go smoothly, we have explored a lot of software tools and platforms to assist us with that, and we have successfully discovered a complete combination of these software tools, and we believe that this method can be passed on to all other iGEM teams, especially the software teams. And if you are interested in the details, you can just go on to our wiki website to see more. Okay, next I would like to tell you about the meetup in University of Science and Technology of China. We held this meetup in August of 2014, and we invited 7 teams in all to come to USTC to have this meetup with us. We talked about our experience and a lot of information, and we also had discussions on the problems and difficulties that we met with when developing the project, and we try to find possible solutions to these problems by cooperation. And we also had some discussion with the laboratory teams. So we'll be able to improve our software and make it more helpful to the actual biological research. And in the end, we also did presentation in front of all the other 17s and the teachers, so we can improve it and make it a perfect one here. Okay, next I would like to take you to have a brief look at the criteria for the medals. So, as you can see, our software has successfully fulfilled all of these criteria. Okay, and so at last I would like to express our special thanks to Deutsche Bank, who has been giving us financial support all the time. And I would also like to express our thanks to Raglan DB, KGG, and Uniprot, from which we have extracted all the useful data to support our database. And we would also like to thank NCBI, MongoDB, and Django for their help in our coding work. Without them, we would never be able to fulfill our project. Okay, so much for our presentation, and thank you very much for listening. We'll be very happy to answer any of your questions.
So I had a question actually for you guys. So I noticed sometimes there are, and I guess you put under your future work, there are these synonyms that appear. Sometimes the same kind of shorthand names. Like, are there ways to disambiguate or to see which version of the synonym? Like sometimes it may be referring to the same node, but there are really two of those nodes. If you could address that.
I think you are asking about the how to trust a result, or
well, just sometimes like you'll have different nodes that look like they have the same name. Yeah.
I see. For some of them, they are different types, and for some, they are actually they are really in same times and same name, but they are from different author. Because our database is open to all the users, and there is actually a cloud database that we did. I will show you there.
And actually, maybe while you're doing that, the second kind of follow-up question is like how big of a network, how many nodes have you ever kind of successfully launched?
Like I will show you an example actually. As you can see here, if I search something and like CRP, and you will see some similar names, but actually you can see these are source. The source is different. It's from different database, and they are in different types. Like these two, and if they are same in the name and type, and they are maybe different in site number. Because we allow users to upload their data and share with others, and how the data is trustful is important. So we use site number to show to all the users and how many users have used this node, and if there are more people use this node, and it shows that this node is more trustful.
And what's the largest size network? Like how many nodes are in the largest network that you've been able to load? Is there like a limit to how big of a network you could have?
How big a network?
Yeah, that you can visualize.
Actually, it is boundaryless. I will show you, and it's almost endless. You can start from a single node and expand almost 1,000. And there are almost 10. Currently, in our database, there are about over 10,000 of nodes, and almost all the nodes can be expanded to another networks, and you can see it's almost boundless.
Have you ever, for example, visualized the whole network?
We're trying to, but it takes a lot of time to visualize this, because this is actually a graphic. But these connections exist as the data in the database, and you can visualize it whenever you want, and any part you want. It just takes a few double tagging.
Let's see if the judges have any other questions.
So I really like the fact in the set of user interfaces that you picked out, that you used to organize your own team. You found that might be helpful for other teams. I like very much that they're commonly available to others. And I wonder, in selecting the ones that you found most useful, did you find them right away, or did you have to play around with different interfaces to pick out the ones that you picked out?
Well, actually, it took us some time to find some of the software to manage in our team, and some others we probably just use them right away. And as you know, there are teams before us, and they might tell us some of the software. So actually, we just try them out again and again. And during this 1-year process, finally, at the end, we can have a most efficient set of software to help us. And I think we would really like to share with others to help them too. It really benefits a lot.
We have another question from the judge over here. Patrick?
So, is it a software to connect the metabolic pathways? And also, how can it relate to the colon sensing you mentioned in the past?
Actually, the colon sensing is just one example of the usage of our software. Our software fits to all kinds of biological networks. And we just show your example of how to use this.
Is it a single cell-based modeling or like a colony-based?
I think you are asking about the database or the content of.
Now you connect them together, and because colon sensing appear when a huge amount of bacteria live together and then achieve some kind of cell density, they will trigger the colon sensing activity. So that kind of simulation need to be based on the population, not a single cell.
You see, we not choose the colon sensing network exactly. I can show you it.
I think you are talking about our result of the CDI-GMP and colon sensing.
Yeah.
But actually, we are software to show the researchers the possible pathways and possible network in a bacteria. And it is not to say that it certainly will work or it certainly is the only pathway. Actually, there are maybe thousands of pathways. We can just visualize it for the users and inspire them to think that whether this will influence maybe his experiment, the result of his experiment. We are not a simulation software. We are a software to show, to visualize.
Visualize all the connections?
Yeah, the connections between the biological substances. Currently, we have many kinds of substances in our database, and there are several kinds of the connections, like this promote, inhibit, and so on. With this, we can show the relationship of the biological network and inspire the researchers.
Did you make the algorithms for the layout, or did you use existing tools?
All the layouts and the front interface is written by code.
Okay, so you developed all that?
Yes.
Okay.
Actually, we are trying to build a platform. This is a platform. We want to show you the BioBrick, and there are also BLAST method to help you in genetic biology research. So this is a platform, and there are actually far more details to show, but time is limited. So if you want to know some of the detail, I can tell you here or at the poster.
Okay, sounds good, thanks.
Yeah, I had a quick follow-up kind of on one of the questions, which was like when you show the different pathways that are possible between two given nodes, do you sort them in a certain order? Like, is there a ranking? Or are they, because you said there may be thousands of them, so how can
Yes,
you
it's sorted by the length of the software. It's
shortest path?
The length, the shortest will rank on the first. It depends on the method we use. The shortest will also in the front.
Yeah. And for the layout, you mentioned that you coded the layout. Which algorithm did you use? Did you use like force-directed layout? Or?
Oh, the layout. This layout. This smart layout is based on force
Yeah, it is for streaming.
Yes, and we use, on Mac there's no GPU acceleration, but on Windows we have GPU acceleration and make this calculation 1,000 times faster. And they can lay out about millions of nodes per second.
Yeah, great, thanks.
Great presentation, guys. It's a very well laid out software tool. Can you tell us a little bit about how you approach the design?
The interface design.
Yes.
Yeah, this it's just read by code. All these animations, all these panels are read in code. Like you see, if there's a window, there's a square, several squares, and several text fields and buttons. It's simply read by code, and this animation is also read by code.
My question is more to do with, before you even got to this, how did you approach the overall design? Did you work with users from the beginning, or did you have hypotheses that you tested? Did you do user testing along the way?
Excuse me?
Did you test with users, and what was your initial design like, and did it change over time?
Actually, this is almost the design from the very beginning, and we make it better, keep it friendly to use. Of course, we are the first users, and we have our teammates. We have teammates to study biology, and we release our software to use ourselves. And if there are bugs, and if they are somewhere unfriendly, and it will report it to the developer group, and we will fix it.
How did you deal with these bugs?
Deal with bugs.
How did you solve the bugs?
Just change several lines of code.
Yeah, but did you have a system that you used to track the bugs?
It's a debug mode.
And we have a system named UTrack, and you can use it easily from bug at biopanel.org. You can just use it, and you can have a try.
Great.
Okay, so I think we're running low on time, so let's thank our speakers one more time.